Division. So what is division exactly? Division is nothing but a method of distributing group of things into equal parts. Say it is what we come across in our daily life almost every day. Suppose we have some chocolates and we need to distribute it among kids. So we have to do it in a way that each and every kids get the same amount of chocolates and they don't feel it is unfair. And so some things, let us take one more example. Suppose we are having a small party and we are providing some canned sodas for your guests to drink. So we have 12 people as guests and you have 30 sodas in your cooler. So how many sodas do you have per person? So if you just do mathematical operation, say 30 by 12, you get 2.5. But we are not going to provide any half soda, 0.5 soda for a guest. So we need compulsory terms like remainder, quotient, etc. So traditionally in our schools we learn something like division is we express it in this way. So you are dividing 30 by 12, you multiply 12 into 2 times, you write 24, then you subtract the 24 from 30, you get 6 as remainder. So this is the final remainder. You can distribute 2 sodas per person and you still have 6 sodas which you can further distribute according to your wish. So let us take one more example. Okay, suppose you have some 217 corona cases and you have 4 hospitals in your vicinity which have some equal capacity. Since it's not possible to treat all people in one hospital, so you distribute the patients among those 4 hospitals. So how do you divide them? So according to our traditional division, so we get 54 as our quotient. So 54 patients per each hospital and you still have one patient. So whom you can allot accordingly. Okay. So we need to be aware of these terms: dividend, which is the total amount, divisor, with which we are dividing the dividend, and quotient, that is, this is the amount actually that each and everyone gets in equal amount, and remainder is the final thing which remains. And why we are going for this remainder thing instead of going decimal things? Because not everything can be split. Okay. So let us learn now how to perform these divisions with respect to our Nikhilam method. So we are taking the divisor 9 here, and it is obvious that the base will be 10. And let us learn how to perform the divisions here. So here we have taken a simple case of dividing 12 by 9. So what will you do? We will shift this 1, which is first digit of 12, to the below of the second digit. We always leave the below space of first digit and we transfer the first digit to the below of second digit. And we add simply. Okay, 12 plus 1 gives us 13. But here you need to notice the separation. So the right hand side of the separation is nothing but the remainder and the left hand side of the separation is quotient. So 9 into 1 plus 3 is nothing but 12. So in 12, 9 divides only once completely and 3 is the remainder. Now let us take one more case. 33 by 9. Similar case. 3 shifts here. You get 36. 9 divides 3 times and you have a remainder of 6. So let us take 103. 3-digit number. Okay. So now we start from here. Why? Because I always said we leave the below space of first digit and we start from the second digit. And now what happens is, as you move to higher digits, you come across the thing that you need to add these all the digits with the digits below. Okay, 1 directly comes here, 0 plus 1, 1, and 1 into the 9's complement with respect to 10, that is 1. Okay, you will understand this further. Now here we are adding 1 and 1 here, and you get 114. So 4 is the remainder and 11 is the quotient. So let us take one more example, 113 by 9, and where we get 1 here and 1 plus 1, 2, right? And that sum we borrow it here, and finally we add everything. So what happens is you get 1 to 5 where 12 is quotient and 5 is remainder. and now 124. So 124, we doing it in the same way. 1 comes here, 2 plus 1 becomes 3, and you add everything. And 13 is quotient, 7 is the remainder. So now you get 1 comes here, 2 plus 1 3, 3 plus 0 3, 3 plus 3 6. And why we are adding all the digits directly? That that question will be answered in the coming numbers. Okay, let us see some more digits for now. And now here is a special case where you get the remainder as equal to divisor or more than divisor. So now when we perform this division once, what you get is divisor is equals to remainder here. So you already know that you can perform this complete division once more. So this is all part of mental calculation actually. Okay, quotient is 2 and remainder is 0. Naturally, we know that 18 is nothing but, a multiple of 9. So these are some of the things which you already know, but here I am writing just to clarify the process, how to deal with this process. So this 2 comes here and 2 plus 2 becomes 4. So 249, here you see once again 9 is remainder is equals to divisor. So that becomes, quotient becomes 25 and remainder becomes 0. So what if the remainder is more than divisor? Okay, we'll perform the division once more. Okay, how we do it? Let us see. This 1 comes here, 3 plus 1 becomes 4 here, and answer we get is 14, 10. So the right hand side part of 14 is 10. Since we have a base 10, we are separating 1 digit and 1 digit. And now we perform this Nikhilam method once again only for this 10. Okay. So here we get something like this. And this one is carried to the left side. And quotient is 15. And remainder is 1. So one more example. 2 comes here. 3 plus 2, 5. And you add everything. 25, 1, 2. And you perform Nikhilam division only for this part 12. And you get 26 as quotient and 3 as remainder. And now let us see how to divide the numbers using lower divisors 8 or 7. Why we are taking this case? This explains, this adds to the clarity of the how to perform this division with respect to Nikhilam method with a more depth. So we are dividing this 23 by 8. So if you observe, now here 2 did not come. Instead 4 came. Okay. Similarly, if you take 7, here 3 came. And similarly, if you take 6, the number below second digit is 4. Why is the case here? Now you understand that actually we are multiplying this first digit with the difference of divisor with respect to the base. Previously we added all those numbers just like that because 9 difference with respect to 10 is only 1. Now 8 difference with respect to 10 is 2, which multiplies with the first digit giving us digit 4. Similarly, 7's difference with respect to 10 is 3. So 3 into 1 gives us 3. Similarly, 6 we get 4. 6 complement 4 into 1 gives us 4. So, but whatever the process is, the beauty of mathematics is you get the same answer and it is never wrong. Okay. So, let us discuss some more cases and take some more bigger numbers. Let us say take some 89 and we are dividing 111 by 89 here. What changes here is the base. Since 89 is closer to 100, we are taking 100 as a base and you can notice that slash change it to after 2 digits from the right side immediately. So 89's complement with respect to 100 is 11 and 11 into 1 becomes 11. Okay. So 1, 2, 2. So 22 is the remainder and 1 is the quotient. And what if we take 73? 79 3's complement with respect to 100 is 27. So that 27 we multiplied with 1 and we add the number here. Accidentally we have digits which start with 1 here. We can see some more digits later on. So now as we increase the numbers, we are taking triplet here. The base will be 1000 and the slash change it to after 3 digits, and 888 difference with respect to 1000 is 112. Okay. So 346 is the remainder and 1 is the quotient. So now let us take one more case. And the thing is, actually in Nikhilam division, we leave the first digits, but we start from the second digit till we reach the last digit. Okay, what I'm trying to say is, see, and we add everything vertically. So this is how we carry out the process. So 1 into 89 complement with respect to 100, 11. 11 into 1. So 11 is added in the first step, and now 0 plus 1 becomes again 1. So 1 into 11, once again 11. 1 plus 1 gives us 2. So now 2 into 11, 22. And now see, we have reached the last digit. Okay. So this gives us the final result where we get 112 as quotient and 45 as remainder. This looks a bit confusing, but actually it's really simple if you understand it. 11001 divided by 88. Okay. So 88 complement with respect to 100 is 12. So we are writing 12. Here 1 plus 1 is equals to 2. 2 into 12 we get 24 in the second step. 2 plus 2 4. That gives us 4 into 12 48 in the third step. And here we add everything. So 124 is the quotient and 89 is the remainder. But 89 is more than 88. So what we do? We do the division once again and we get 125 as quotient and 1 as remainder. So one more, let us take one more case, 198 by 97. So the advantage of Nikhilam method is we can perform it easily with respect to higher numbers. Why can we do with respect to higher numbers? Because their complements, their differences with respect to the base is too low, and that makes the calculation pretty easier. 97 is just 3 digits away from 100. So we just have to add 3 here and we get 101, out of which we already know that 101 is more than 97. So we perform the division once more and that gives us quotient as 2 and remainder is only 4. So this method is pretty good for large digit numbers and not for small digit devices. Why? Because small digit devices also we can perform it, but the thing is the process will be very lengthy and it consumes a lot of time and just adds to the confusion. So it's just not preferred. It's not wrong exactly. Okay. So thank you. Any more questions? Please comment in the section below video and I'll be glad to answer all of your questions.